A very wise first step in attempting to understand the graph of a polynomial function is to understand that a polynomial function can be factored into, sometimes into just linear factors like we have here. Sometimes they're quadratic factors. Go back to the full set of notes to see what we do with quadratic factors, but just to remind you and show you what generally is going on, let's look at a graph of y equals some constant c times x minus x1 times x minus x2 times x minus x3. It should be very clear that if x equals x1, we're going to get 0. So at x1 we're going to have a 0 of the function. Similarly at x2 and x3. We then have to look at the far left and far right behavior of this function. If at the far left x will be a large negative number, which means this times this times this will be a large negative number, then if c is positive, the function will have to be up over here. And it'll come down through this 0, up through this one, down through this one. And I think I just said that wrong. If x is a large negative number, all this will be negative, so c is positive. We're going to be negative here, so we're going to come up, then down, then up, which is consistent with what happens if x is a large positive number. All these multiply out to be a very large positive number. Multiplying by c, we have to end up at the far right. If c is a negative number, we have the graph that we see, where a large negative x gives us a negative here, then a negative c gives us a positive, so that for large negative x we're positive, we come down, we come up, then we go back down. And of course, when x is a large positive, all these will be positive, so c is negative, will end up negative, as we see here. Number 47 is related to vertical asymptotes and rational functions. If we have y equals some constant times x minus x1 over x minus x2, it should be clear that when x equals x1, we're going to get 0. So we have a 0 at x1. It should also be clear from discussions and so forth that as x approaches x2, the denominator here is going to approach 0, and we're going to be dividing 0 into something that's not 0, provided x1 is not equal to x2. So that we're going to have a vertical asymptote at this point. If c is a positive number, then what we're going to have is going to look like this. If c was a negative number, it would look kind of like an upside down version of this, where the asymptote would be negative here and positive over here.